All right, guys. So we're still on page 86, and we're picking up on question number 9. Now, question number 9, we can see here that we have one isosceles triangle, and we can see here that I have another isosceles triangle. And I can see here that these two base angles are congruent, but I can't set them equal to each other because this has a y and this has an x, and they're not like terms. I know that this is 2x minus 25, and this is also 2x minus 25. But if you try to set an equation for it, all you're going to get is an all solution. Let me show you what I mean by that. If I say 2x minus 25 is equal to 2x minus 25, here's what we're going to get. We're going to get 2x is equal to 2x. And if I divide both sides by 2, x is equal to x. That doesn't help me any. That doesn't tell me anything. So there's actually something that they should have told you in this question, and they didn't. And this is shame on them. This is their bad. They should have told you that these lines are parallel. Because if these lines are parallel, then this right here is a transversal, and then what we have is alternating interior angles. And we know that alternate interior angles are congruent. So that now I can set these two angles equal to each other. So I can say that 2x minus 25 is equal to x plus 5. So let's plug that in here. Okay. And now let's do some algebra. So 1x comes out to be 30. So I know that x is equal to 30. And again, the only way that I was able to do this equation is if they would have told me that these two lines here are parallel, and as a result, making these two angles here alternate interior angles. This is my transversal. These angles are on different sides of the transversal, and they're inside the parallel lines. If you remember, those are alternate interior angles. Well, now that I know that x is 30, I can solve for these angles. Well, x plus 30 is going to give me 35. So this angle here is going to be 35 degrees. Well, now that I know that this is 35 degrees, this angle here is also going to be what? Equals to 35 degrees. So I can say that y plus 28 is equal to 35. And we can solve that. Y plus 28 is 35. Subtract 28 from both sides. And y is equal to 7. So y is equal to 7. And if you look here, 7 plus 28 is 35. And do I really need to figure out this angle here? Not really. They're not asking for it. But let's do it anyway. If x is 30, which we said before, we said that x was 30. Well, 2 times 30 is 60. Minus 25 is going to give you 35 degrees. Let's see. 2 times 30 is 60. Minus 25 is 35 degrees. So this is 35 degrees as well. And that shouldn't surprise us because these are alternate interior angles which are congruent. Now, guys, we're moving on to page 85, questions 6 through 14. And again, they're asking us to solve for x and y. Please remember that these triangles are isosceles triangles. So I know that this is the vertex angle. I know that these are the base angles, and they are congruent. So if this is 72 degrees, I know that x should be 72 degrees. And it's very easy to find y because we know that a triangle has 180 degrees. So if I add these two together and subtract it from 180, I'll know what the vertex angle is. So 72 times 2 is 144 minus 180. It's going to give me 36. So y, we know, is going to be 36 degrees. Looking at question number 7, again, I have an isosceles right triangle, so I know that this is 90 degrees. I know that these two angles here are going to be 45 degrees because 180 minus the 90 leaves me with 90 degrees that I have to split between these two angles. So 90 divided by 2 is 45. So this is 45 degrees, and this is 45 degrees. So right away I can see that x is 45 degrees. Hopefully, we remember that these are what? These x and y are a linear pair, which means they add up to 180. So if x is 45 degrees, it's pretty simple to find y. All I have to do is 180 minus 45. And that's going to give me 135 degrees. So y is equal to 135 degrees. So x is 45 and y is equal to 135. Number 8, I have an equilateral triangle. All the sides are equal. And if you remember the rule, if all the sides are equal, then all the angles are equal. And I have 180 degrees inside of a triangle. If I divide that by 3, which are the 3 angles inside the triangle, which are all equal, I'm going to get 60. So all of these angles here are going to be 60 degrees. If this is 60, please remember that these are a linear pair. So if I subtract 60 from 180, it's going to give me the value of y. So y is going to be 120 degrees. Moving on to question number 9. Again, they're asking us to use the rules of congruency. I have an isosceles triangle here, and I know that in an isosceles triangle, the base angles are congruent. Right away, I can see one of the rules already. I have an angle, a side, and an angle, matching the same angle, side, and angle. So I know that these two triangles are congruent by the angle, side, angle rule. I also know that this side is congruent onto itself. And if you notice here, I have a side, an angle, and a side, congruent to the same side, angle, and a side. So I can say that these two triangles are also congruent via the side, angle, side rule. So I have 2 rules that I can use to prove these triangles are congruent. Again, one is not better than the other. Number 10, these are congruent angles, these are congruent sides. I know that this side is congruent onto itself. So I notice that I have an angle, a side, and a side. And we know that angle, side, side is not one of the rules for proving congruency. Number 11, now they're telling me that I have parallel lines. That's very important, because if these are parallel lines, then, ladies and gentlemen, what I have is this, then this is a transversal. And if this is a transversal, then this right here are alternate interior angles. And if these lines are parallel, then this is also a transversal, and these are also both alternate interior angles. And if you look closely, these we know to be vertical angles, which we know are congruent. So I can say that these 2 triangles are congruent via the angle, angle, angle rule. If you look closely, we can also say that we have an angle, a side, and an angle matching the same angle, the same side, and the same angle. So again, we can say that these 2 triangles are congruent via the angle, side, angle rule. And if you notice, I have an angle, and then a side. And then again, I have an angle, and then a side. So we can also say that these triangles are congruent via the angle, angle, side rule. Now, if you didn't see all 3, that's okay. Don't worry about it. As long as you got one of them, you're in good shape. But I just want to show you all of the possibilities. Are there any other rules that we can use here? Not right now, not that we see. Let's move on to number 12. Question number 12, they want us to solve for x. They tell me that this is an isosceles triangle. So this is my vertex angle. These are my two base angles. And we should all know by now that base angles are, if you guess congruent, you are correct. So this angle here is also going to be equal to 3x plus 8. And if I add them all together, they should equal to 180 degrees. So let's do that here. Let's set them all equal to 180. So I'm going to have, by the way, that's a little bracket there, 3x plus 8 plus 3x plus 8 plus 2x plus 20 is equal to 180 degrees. Okay, I'm adding up all the angles together. Let me combine my like terms. 3 and 3 is 6, plus 2 is 8, so that's 8x. Plus 8 and 8 is 16, plus 20 is 36. That's equal to 180. So x is equal to 18. So for number 12, we took all the angles, added them together, set them equal to 180, and we got that x is equal to 18. Let's take a look at number 13. Again, I have an isosceles triangle. These sides are equal. I know that these base angles are congruent, so this is 40. This is also going to be 40 degrees. If I add them all together, they should equal to 180. So let's do that. Let's 40 plus 4x plus 10 should be equal to 180 degrees. That's going to give me 40 and 40 is 80 plus 4x plus 10. Now 80 plus 10 is 90, so I can just write 180. And now we're going to take 90 divided by 4. And we're going to get 22.5. So x is equal to 22 and a half. So for number 13, x is equal to 22.5. Again, guys, remember, if this video is going a little bit too fast, you can go back to the YouTube page and review it anytime at home. Finally, for number 14, I have two isosceles triangles which are adjacent to each other. I have this isosceles triangle here, and I have this isosceles triangle here, where this is my vertex angle, and these are my two base angles. I know that this is 54, and I know that these two angles here are congruent. So I'm going to take 54, subtract it from 180. That means that I have 126 degrees left in the triangle, which I'm going to divide between these two angles here. So that means that each angle is going to be 63 degrees. So this angle here is 63. This angle here is 63. I hope you can recognize that these are a linear pair, meaning they should add up to 180. So 180 minus 63 gives me 117. So this angle right here is going to be 117 degrees. By the way, this angle happens to be the vertex angle of this isosceles triangle. So I can find out how many degrees I have left to use between these two angles by subtracting from 180. So 180 minus 117 is 63. And now I have 63 degrees that I have to divide between these two angles. So I get 31.5. So x is 31.5 degrees, and this angle here is also 31.5 degrees.